Hi, my name is Simon Sun. I'm a research engineer at NAIT's Applied Research Center for Energy and Environmental Sustainability. My main specialty is in tailings management and more specifically in oil sands tailings management in Alberta. What exactly are tailings? Is it just mud? Or is there more to it? So tailings are the leftover waste byproduct after bitumen is mined from bitumen ore. So the main components of tailings are clays, water, some residual sands, and chemicals that were used in the extraction process. So it may not be the complete story to say that tailings are just mud. Tailings are like mud, but mud is not like tailings. So tailings does contain some components like salts and chemicals that we don't necessarily want leaching into the environment. Why are tailings created in the first place? Imagine you're eating a chocolate chip cookie, but your favorite bit is the chocolate chips. You're not allowed to just eat chocolate chips. You have to eat the rest of the cookie as well. The same thing goes for mines. You're not allowed to only mine the richest bitumen ore. You kind of have to take everything else with it too. And what comes with bitumen ore or oil sands ore is the clay that originally existed in those landforms. And those clays, they're not very valuable to the extraction process. In fact, they are actually a detriment. They end up in the tailings because they're not a valuable product. And the clays themselves introduce a lot of further troubles when it comes to actually trying to make the tailings settle and consolidate. So companies definitely aren't creating tailings just because they want to. It's because it's a waste byproduct of the bitumen that they do need to mine out of the earth to create further valuable products, petrochemicals, plastics. We hear a lot about tailings ponds. Are these basically just lakes of waste? What is stopping them from leaking into groundwater or the nearby rivers? So to call them just tailings ponds is doing a little bit of disservice into how much engineering goes into designing these tailings storage facilities, which is the technical term for them. There is challenges in managing the waste that goes into these tailings storage because Alberta operates under a zero waste discharge policy for the oil sands. And what that means is any drop of water that is affected by the process is not allowed to be released back into the environment. It all needs to be contained on the site at which it was produced. And that goes for water that falls onto the site as well through rainwater or snow water. So these companies end up needing to manage huge amounts of water. You know, this is a huge amount of waste that these companies are responsible for dealing with. So as for whether or not it leaks into the river system, the Athabasca River is constantly being monitored for things like heavy metals, for salinity, to make sure that none of the tailings waste leaches into the water and affects downstream communities. And that is especially important because we have to recognize that people live in nearby areas. Plants and animals rely on that fresh water as well. As for groundwater, so when these containment facilities are built, they are layered with fine clays and with lean oil sands, and that creates a very impermeable, a very low permeability layer that reduces the amount of contaminant that is able to leach into the groundwater. The tailings themselves have very, very low permeability and low hydraulic conductivity, which is part of what makes them difficult to manage and dewater to begin with, and that again reduces the amount of contaminant that can be leached into the groundwater. Another layer of safety that is added to these containment facilities is seepage wells. So any water that does seep past the low permeability layers is directed into a well and pumped back into the pond, and eventually that water can be recycled. Finally, around all of the storage facilities, there is groundwater monitoring to make sure that contamination doesn't actually end up into the groundwater. So that is the final layer of defense for groundwater seepage. How are tailings managed and stored safely? So many different companies use many different solutions to store their tailings and to manage their tailings volumes. It all comes down to trying their absolute best to get as much water as possible out of the tailings, and there's a few main strategies. So one of the biggest step changes to tailings treatment performance over the last couple of decades has been inline flocculation. That is when a polymer is dosed into a tailings flowing through a pipeline, and that polymer's role is to collect those clays into larger and larger aggregates or flocks, and that allows them to settle more easily once they end up outside of the pipeline when they're deposited. Another strategy that some companies will use is a co-mix, so mixing tailings with a coarser sand. The goal here is to hide those clay particles in between the spaces of the coarser sand grains, and that allows for a more stable, structured material fabric that also allows water to pass through. So some companies have had a lot of success using that strategy. Other strategies include things like thickeners, so you can imagine a thickener as kind of like a water treatment process, or a giant tank that's constantly being mixed. Reagents are added in to help those clays settle out, and clear water is usually able to be withdrawn from the top, and the coarser settled solids are taken from the bottom. Some other companies are also using centrifuge, so imagine a giant washing machine that is spinning and swishing the water out, capturing all those solids, but that is a very energy intensive process. Why does it take so long, decades or maybe even centuries, for the fine clay particles in tailings to settle naturally? Clays are the main troublemaker in our tailings, there's no doubt about that. Clays are very, very fine particles. In this field of research, we call them colloidal particles. And what that means is they exist at around the scale of 1 micron, so about 1,000 of them can fit within a millimeter. And what that means is at those really, really small particle sizes, really tiny forces start to dominate their behavior. And these clay particles just so happen to be charged. So they all have their own surface charges. For kaolinites, the face of the particle is charged differently from the edge under certain pHs. So all of that causes very big headaches for actually trying to get them to come together. Because it turns out each of these clay particles has a tiny little force field, a tiny little electrostatic sphere around it that prevents it from getting very close to another clay particle. Which means these particles exist very stably in suspension in water, and they're not able to come together and they don't separate. So a nice household analogy might be a glass of milk. If you leave a glass of milk on the counter and you make sure that it stays fresh, somehow the water will probably not separate right away, and it won't separate until you start to see the milk curdle. That is when the milk starts to, due to bacterial interaction, the milk may start to form clumps, and that's obviously very bad for your milk, but the water does come out that way. For tailings, it doesn't naturally curdle, but we do introduce reagents like coagulants and flocculants, which are either ionic agents or polymers that help those clumps start to form. And that's really where we start to see the dewatering action happen. It's when we can convince those small particles to become bigger and bigger particles or aggregates. So in our lab at NATE, we test a lot of polymers from a whole bunch of different manufacturers to understand what is the dosage that's required, what is the performance that we can hope to achieve. And we also help a lot of these small to medium enterprises test their own novel technologies to help them understand how do they stack up against commonly used reagents in the industry, what are the benchmark values, how does their performance compare, and we try to help them enter the market by doing standardized testing for them. How can better measurement and monitoring of tailings components lead to more effective and efficient treatment methods? So when we think of tailings, we think of just one fluid. It's very easy to just assume that all tailings are alike, but actually nothing could be further from the truth. Even at one specific site, the tailings that you get at 6 o'clock in the morning may be very, very different from the tailings that you get at noon, and again, different from the tailings that is flowing through the pipeline in the evening. So depending on the oil sands process, depending on the ore body that is being mined on that particular day, depending on any process upsets along the way, tailings characteristics and their composition can be very, very different. And that means the behavior of the reagents that is being added to treat the tailings has to account for all these process variability. In other words, we need to make sure that the reagents are robust and able to handle all kinds of process variations and give good performance across a wide range of characteristics. So that is why it's so important to understand what is in our tailings to begin with, what components are going to be well received by some reagents, or what reagents are going to behave poorly when you have an abundance of this type of mineral or that type of clay. That is where advanced characterization really starts to come into play in our lab. How is technology changing the game? Are we getting better at cleaning this up? What is NATE doing to help solve these problems? Tailings are usually moved by pipeline around the sites, but it kind of all depends. So if the tailings have been out, one of the treatment methods is just to leave them out and allow the sun to dry them. If they've dried to a certain solids content, they can then be trucked around. And that is a different way to remediate the tailings, by covering it with an overburden and then trying to plant trees on top. We've done some research in the past that has had some success in growing plants on tailings. When we think of trees and shrubs and grasses, their whole reason that they can live is because they can extract water from clay-based soils, especially in northern Alberta. In a lot of these ways, plants are nature's own way of dewatering clay-based soils. We just have to make sure that the tailings are able to support the plants in terms of nutrients. That is something that tailings naturally lack, but we have done research in the past that shows if we can amend the tailings with certain micronutrients or organic nutrients, the plants are able to grow nicely, they're able to grow stably, and more importantly, they're able to remove water from the tailings, which is what we really want. So one of the inspiring things I've encountered in my last 6 years of working here at NATE is the performance of these tailings treatments is getting better year over year. And a lot of that is because we're constantly getting new innovations from big multinational chemical manufacturers all the way down to these small garage inventors who all have novel ideas and ways to improve the treatment process. And we're really proud to be able to help these people by testing their products in our lab. So what we can usually offer to the industry, whether it be the oil sands industry or the technology providers that support them, is a method of standardized testing. So in our lab, we have a huge volume of tailings that we can test out with different reagents to see how they behave, see how the behavior is different, and how the performance can be impacted by the tailings characteristics. And in doing those standardized testing, we help our industry partners and other technology providers understand how does their technology behave and how does their technology benchmark against things that are already commonly accepted in the industry. It's become more and more clear to me that the solution to tailings from a technology perspective probably already exists, but what we also need to keep in mind that a lot of these technology implementations also depends on culture and the willingness to work in a multidisciplinary, inclusive environment that helps everybody thrive. So the more and more I work on tailings, the more I realize it's not just the specific reagents and the specific tests that we do, but it's also the people who are involved. And I'm also proud that in our research team, we also help a lot of technology providers meet our industrial partners and help them just get to know each other and help get their technologies out there and start to think, what are the potential solutions that can be implemented, that we can test today, that can be implemented tomorrow. So that was your tailings questions answered for now. Thank you for watching, and please stay tuned for future videos.